Factoring special binomials. Given that A and B represent algebraic expressions, difference of two squares or A squared minus B squared is the product of A minus B and A plus B. The difference of two cubes or A to the third minus B to the third is a product of A minus B and A squared plus AB plus B squared. Sum of two cubes or A to the third plus B to the third is the product of A plus B and A squared minus AB plus B squared. For the perfect square trinomials, A plus B quantity squared is the same as A squared plus 2AB plus B squared, and A minus B to the second power or A minus B squared is similar way. So we get A squared minus 2 times AB plus B squared. Now, in this example, we are going to use the special factoring patterns to factor the following expressions. In part A, we have 81 minus x squared. As you notice, there are two terms, and one of the terms is obviously in the power 2 or the square form. So we are going to use the difference of the two square pattern. I'm going to put a note here. I'm going to refer to the difference of two squares as A squared minus B squared equals the quantity A minus B times A plus B. So we're going to write 81 minus x squared as the quantity squared minus quantity squared. 81 is 9 quantity squared, and x squared means the x squared. So in this case, if we follow the pattern, we could see that A as the 9 and B as the x. So then we're going to have the pattern of the sum and multiply by the difference or vice versa of the quantity A and B. Note here, so since A as a 9, it's going to be 9 minus x multiplied by 9 plus x, as we factor this expression using the difference of two squares pattern. And then the second one, or part B, we have 25x squared minus 4. Its difference, the quantity is in the square form. So another example using the difference of two squares. We have 4, so we can write 4 as the quantity 2 squared. For the 25x squared, we're going to write the whole expression, the whole terms there as one single quantity raised to the second power. As we know, 25 is 5 to the second. 5 to the second times x to the second. So that becomes 5 times x as one quantity raised to the power second. Right now, we have in the form of a squared minus b squared, which means the a for our case is 5x and the b for our case is 2. And then follow the pattern of the difference of the two squared. We have the product of the difference and the sum. So the difference would be the 5x minus 2, and then the sum would be 5x plus 2. And now we are done factoring using the pattern of the special product. And then the last one, y to the third plus 512. This is a sum, and y to the third represent the cube of the quantity y. So we're going to rewrite it as the quantity y to the power 3 plus some quantity raised to the power 3 as well. So that would be the value 8 to the third power. So in this case, we're going to have the pattern of the sum of two cubes as a to the third plus b to the third, and factor to be a plus b multiplied by a squared minus a times b, and then plus b squared. And follow the pattern where A is y and B is the value 8. We have the first factor as A plus B, which is y plus 8, and then multiply by the A squared, which is y squared, and then subtracted by A times B, which is y times 8, and then plus b squared will be 8 squared. And simplify in a nicer form, we have y plus 8 multiplied by y to the second minus 8 times y plus 64 as a result.